morning, everyone. I'm Alexandru Artenie, and I'm project manager and group leader of PREH company in the division of e-mobility. And as my colleague mentioned, I will talk today about why we should use electric vehicles, what's the advantage of an onboard charger, but bidirectional one, and how PREH company is supporting the development of e-mobility. First of all, I want to ask you if you ever thought how much CO2 emissions come from a traditional car. According to the estimates, the cars produced in Europe in 2022 produce about 110 gram per kilometer. And if you multiply this per 1 year, we have 1,500 kilograms per year new cars produced in 2022, according to the new rules of pollution emissions. So let's now add the new and old cars in order to understand and estimate at the global level of the CO2 emissions. And we have this figure of 3.5 billion of tons of CO2 per year, 3.2 billion every year. That's the production that amounts to the production of wine in Moldova during 25,000 years. So now we have this question: whether could we absorb or use all the CO2? Yes, obviously, yes, we could, but we should plant the whole surface of the Republic of Moldova with forests 107 times. 70 times, sorry. And we need also to look at the trend of CO2 emissions because it does not show any signs of reduction. Even though we had some reduction in the pandemic, we've came back to the trends before the pandemic, and that's how we end up with landscape like this one, or the next one. Obviously, we should do something to reduce pollution. Would this be the electric vehicle that would bring the solution? Let's look at this. We all know that electric cars contain lithium, and the extraction of this product is quite complicated and polluting. And the process for processing this and creating of electric cars has created real debates in relation to this. And to this, we add emissions associated with transportation, storage issues, and not to mention the fire risks. Okay, now let's try to have an exercise to look at three CO2 emissions scenarios for three types of cars produced in Europe: the gasoline type car, the diesel car, and electric car. Let's look how much emissions they release during the production process. We see that the electric car produces much more CO2 from the first stage before even running the first kilometer. Obviously, after that, we'll have some pollution due to the CO2 emissions associated to the production of electricity. Now, let's look at the emissions of CO2 while using the fuel. Well, while being exploited using a specific country, Moldova, the electric car still is winning, but it does not seem to save the world. So why do we have so much agitation, so much debates about this electric vehicles? We have the same study done in Sweden, and we can see that once the electric car is produced, the car does not produce CO2 emissions anymore. And what's the idea? It's the source of energy, and we can see that Sweden uses the highest rate of renewable energy in Europe, and we can see now that the process of producing electric cars is part of a broader image. An additional perspective of this element would be the non-equal process of your energy consumption. Let's look at the domestic use of energy during 24 hours. Well, during the night, we do not use at all energy. When we start to wake up, we make coffee, prepare coffee, and we have the IT guys preparing the coffee. Then we have our lunch, use microwaves to from the lunch, we have our siesta and different house chores, and by the end we prepare for the night for sleep. We can see that it's not a there is a non-homogeneous profile of energy consumption, and we can see that there are some tops of energy use, and we have hours when we do not use almost at all energy. Well, don't you think if we had a battery that we might charge during the uh, lowest periods of consumption, uh, and later on during the peak periods to use the energy from this storage battery, that's how we would avoid overloading tops. So in this sense, we might charge this battery during the night when they have preferential prices, and to give back to the grid during the day. And that's how we gain some benefits, economic benefits. But the most important is that such a battery would help to integrate renewable energies. First of all, it might help to store the excess surplus of energy when production exceeds the consumption, and to give back to the grid the surplus and to take something from the grid. And second, it would help have a more soft, more equal process of use. But the use of renewables puts issues in terms of climate conditions, weather conditions, because if you have sun, we have energy. If there's no sun, we do not have energy, and the same is with the wind energy. This is not the only system we should use, but this would help us compensate the energy consumption. The question is, where do we get such a battery now? Well, by accident, the electric vehicle is a big battery on wheels. It's such a huge battery that it would be sufficient to supply energy in for a house in Moldova during 10 days consecutively. This is related to the concept of vehicle to grid and includes a bidirectional flow of energy between the car and the grid. That's the flow where we could also include the renewables, of course. It's a concept that might extend under more broad forms known as smart grid, where every consumer, customer, and every producer is managed in a smart way. Not less interesting is that vehicle to grid is related to different derived applications like vehicle to home or vehicle to load, and this would help us supply power to consumers that are totally disconnected from the grid. For example, a cottage in the mountain, or we can use a vehicle to bicycle, or even why not a vehicle to grill. The most important benefits from a vehicle to grid application is that it helps stabilize a grid, can serve as urgent or emergency charger, and helps integrating renewables, and serves gives economic benefits, and is compatible with derived applications like vehicle to home or vehicle to load. I think that we've also seen that electric vehicles are a piece of an immense, huge puzzle of the sustainability, and this other piece in that puzzle is PREH company. Let me tell you something about us. Our company has been working more than 100 years in the electronics sector, and for more than 40 years in automotive sector. We are present all across the globe, including in Romania, Brașov, and Iași, where we have research and development centers. We have different clients: Volkswagen, Ford, BMW, or even Tesla. We work in three big departments: commercial vehicles, human machine interface, and e-mobility. And even though the e-mobility department, which I'm part of, is only 18% of the company, we still have a lot of products we are proud of, like this combo box for Porsche Taycan. It's an outstanding product which by its which is shown by its complexity and multifunctionality. Let me explain you why. As you can see on the right side picture, this unit includes two modules. The first module, in its turn, includes three DC-DC converters, one 48 volt, one 12 volt, and one 400 volt. The one of 48 volts is meant to support the roll stabilization, which gives a high stability at the curves. The 12 volt one is used for charging different systems of the car, like brakes or infotainment, and the 400 volts converter is used for uh, supplying the AC system in the car. And these all are included in a converter as small as all these elements are included in a space as small as possible. This second unit, the second module includes two units, a power distribution unit and a booster unit. Let's see what they do. Well, normally, a car with a battery of 800 volts can be charged at a DC station of 800 volts without any issue, and our distribution unit allows for powers up to 350 kilowatts, which means about 18 minutes of charging for the Porsche Taycan. But what happens if the DC charging station is of 400 volts? In that case, basically the charging process is not possible because the two voltage levels are not compatible. We have 400 volts of the charging station versus 800 volts of the car. And in that case, we use our booster unit, which basically increases or doubles the voltage of the charging station and brings it to the same level with battery of the car and makes them compatible. It's an extremely important unit which increases the level of usage of the charging infrastructure. Without this unit, it would not basically be possible to use the DC charging unit of 400 volts for Porsche Taycan, for example. But you shall know that we're not limited only to sports car. We have other elements like onboard chargers, the single phase of 3.6 watt for Volvo XC40 hybrid, or the 11 kilowatt for commercial Volvo vehicles. And that's a unit that could combine up to four elements in parallel to give power or voltages up to 44 kilowatts. What does the board charger do? Onboard charger. It connects to the alternate power source and it transforms this energy in a car, continuous direct the current, and this is compatible with the battery of the car. Without the onboard charger, we would not have the possibility to charge the battery in the domestic conditions. Oh, well, alongside with this, we work on BMW or Mercedes E-Class 3. All these products are in the mass production in our organization, and you can find them in the cars that are just now traveling on the streets. And the new generation of DC-DC Plus booster and now the new onboard charger, and I can tell you about this only that it's bidirectional and supports apps like vehicle to grid, vehicle to home, or vehicle to load. These are some of the modules that PREH company is producing in order to contribute to a greener world. To conclude, I encourage every one of you to take part in preserving the environment regardless of the piece of puzzle that we represent any of us. Together we will manage to have a cleaner world even in the urban areas and to enjoy greener landscapes like this one, or this one. Thank you.